Hello, everyone. My name is Sridhar Kulkarni. I'm a product manager in the AWS VPC PM team. I'm responsible for a couple services, Cloud WAN, Transit Gateway, and some of the VPC features. And we are here to talk about an exciting new feature called VPC Block Public Access.
Hi everyone, this is Ankush Goyal. I'm Senior Technical Account Manager at AWS. In today's video, I'll give you a quick demo that will help you to understand how VPC Block Public Access feature works with different scenarios. Thank you, Sridhar.
Awesome. So I'm going to kick it off. So before I take a deep dive into what this feature is all about, I'm just going to set up some quick context. So as you know, VPC is a very fundamental networking service that lets you have your own private isolated environment within AWS. And it has very powerful external connectivity mechanisms as well. One of them being able to connect to internet. So it's super easy, as you know, to attach like an internet gateway or an EIGW to the VPC, assign a public IP address to instances, configure the route table, and then those resources get public internet access. The flip side of this is, as a central network and security admin, I want to make sure, or it's one of my critical responsibilities actually, to ensure that there's no unintended internet access in the VPCs. And so we have some controls already, like security groups and NACLs and all of that. But a lot of times, many of our customers, have hundreds and thousands of VPCs, and in many different environments, like dev, test, production, or there could be accounts and VPCs for different BUs. And so in shared environments like that, having multiple controls, could be and not such a scalable solution if you want to just block internet access in all these VPCs. So over and over, we have heard this feedback over the years that, hey, give me something super easy to block or control internet access in my VPCs. And that's what VPC Block Public Access feature is all about. It's a single-click declarative control that admins can use to authoritatively block internet access in your VPCs. And the reason we say it's authoritative is because it supersedes your existing VPC configurations. So you may have, and oftentimes we've heard, the customers have misconfigured network settings or security group settings, and then default routes to internet gateway, which ends up in internet access. And so this one authoritative control will actually supersede any of that configs that you may have that gives that internet access in the VPCs. And from use cases standpoint, obviously, like centralized security enforcement is a big use case. It provides network admins with that peace of mind that, regardless of what configuration may happen in their VPCs, from different app developers or different BUs, they have that peace of mind that, hey, internet access is blocked in the VPC. And then compliance is a big thing as well. So as you folks know, it's not just about implementing security controls, but also as an admin, you must be able to prove to internal and external stakeholders that indeed your VPC is protected from unfettered internet access. So this feature also helps, with that aspect of things. And so just digging a little deeper into what, the features, the sub features are as part of this block public access feature, it gives you the ability to block all egress traffic via your internet gateways or your EIGWs. And you have two modes: bidirectional mode, which blocks all bidirectional access in the VPC. And then there's also Egress-only BPA mode. This is where only inbound connections from the internet are blocked. Outbound connections are fine. So any NAT gateways in your VPC, this control will allow that access to happen, but it won't allow any unsolicited connections coming in from the internet to resources in your VPC. Now, we also have a notion of exclusions because we want to keep this real world. And there might be some applications which need internet access, in which case you can say, hey, this subnet in my VPC has a NAT gateway or has a certain web server, and that must have access to internet. And then you can do that. You can exclude that subnet from BPA enforcement. and everything else is, blocked. Similarly, you can exclude VPCs as well. This is an account level control, and you can say, hey, such and such VPCs, leave them out of BPA. Now, there's also integration with Network Access Analyzer. Now, this support provides you the visibility to do impact assessment. So before clicking on this big red button, you can run a Network Access Analyzer scope and figure out, hey, these are the resources that are going to stop accessing internet when you turn this control on, right? So that way you can decide, hey, whether I want to do any exclusions or whether it's okay to block internet access to these resources. There's also flow level visibility. So it's integrated with VPC flow logs. It's going to give you drop packet counters and so on and so forth for VPCs that have BPA enabled. And then last but not the least, we also have organization level support. So we launched declarative policies at reInvent, and that gives you a very scalable mechanism to implement this control at your org level or your organizational OU level. So that sums up the what the feature is all about. Just a quick note again, what's impacted, what's not impacted. Though, so all, as I said, it's an IGW focus feature. So anything Internet Gateway, IGW, NAT Gateway, Internet facing NLBs, ALBs, AGAs, all that traffic is blocked when BPA is enabled. Services that are not impacted are the ones that are very private in nature, right? Like private link or transit gateway, which is private access within a VPC, VPC peering, or private V2N interfaces. So stuff like that, it's outside the scope of this feature. So with that, I'm going to hand it over to Ankush, and he has an excellent demo on this.
Thank you, Sridhar. For this demo, we have a VPC which has two public subnets and one private subnet. Instances in the public subnet have connectivity to the internet via internet gateway, and instances in my private subnet have connectivity via NAT gateway or egress-only internet gateway. Next, we'll go to the console and see how this setup looked like. I've logged in into my console, and from the resource map we can see my public subnet A and public subnet B has connectivity to the internet via internet gateway, and my private subnet has connectivity to the internet via NAT gateway and egress only internet gateway. And these are the four instances which are running in this VPC across these three subnets. Now we have a requirement where we want to block all the traffic, all the public access from these instances. That means that these instances should not be able to reach to the internet, and no client from the internet should be able to reach to these instances. Let's see how we can use block public access to block all the traffic for these subnets. To block the public access to this VPCs and subnet, we'll go to the VPC dashboard, scroll down to the bottom of the menu, and we'll click on settings. Here we'll see the block public access feature, where we click on edit public access settings and we'll turn on block public access. In this case, we'll choose bidirectional internet gateway block direction because we want to block all the traffic which is coming to these instances as well as traffic going from these instances to the internet. And we'll click on save changes. Okay, so our block public access status is on, and it took few minutes to apply this setting to all the VPCs. And like the warning here, the warning says that when you enable the block public access, it blocks the internet traffic for all the VPCs under that particular region. If you want to exclude any particular subnet or VPC, you can add those under the exclusions, and I will cover those use cases shortly. So next, let's go to our instances. We'll log into those instances and see whether we are able to connect to the internet or not from those EC2 instances. So let's try to connect to our first instance A, which is in my public subnet A. I'll click on connect, and we will use our instance connect endpoints. And I'll try to ping amazon.com. Here you see my EC2 instance is not able to connect to my internet. Next, we can try one from our private subnet. Let's pick up this instance C and connect. And as you see that we are not able to connect to the internet from our private subnet as well. For our second use case, we will exclude public subnet B by using bidirectional mode from block public access. And once we exclude it, the instances in my public subnet B should be able to reach to the internet, and any instance which is using this NAT gateway in the subnet will also be able to access my internet. In this case, like instance C. So let's go to the console. Let's see how you can exclude a subnet, and then we'll try to connect to these instances and check the internet connectivity. In the console, we'll click on create exclusions and we'll give a name. We'll give a name as subnet B. And then we'll keep our allowed direction as bidirectionals in this case, and we'll select our subnet ID. So this is the subnet for my VPC BPA public subnet B. We'll select that and we'll click on create exclusion. Okay, so status is active. Next, let's go to the instances. We'll first connect to my instance B, which I've already opened, and try to connect to the internet. And as you can see that we are able to connect to the internet. Next, let's connect to our instance C and we'll try to ping amazon.com, and you are able to get the result. Next, I will log into my terminal and will try to connect to these instances from my terminal. So let's pick up the public IP address of the subnet B and we'll ping. As you can see, we are able to reach to this instance from the internet as well. Similarly, let's take the IP address of my instance A. So as you see, we are able to connect to the internet from instances in my public subnet which is excluded, but the instances which are in subnet which are still are not under exclusion and which are blocked by the public access are not able to reach to the internet, or internet cannot reach to these instances. So our next use case will be where we will exclude only our private subnet C, and this time we'll use our exclusion mode as egress-only mode. When we do that, only the instance T which is connecting to the internet over IPv6 will be able to connect, and all other instances will be blocked from the internet access. So let's go to the console and see how we can do that. So we will exclude the subnet C the same way we excluded the subnet B. The only difference will be, in this case, the traffic mode will be egress only. We selected our subnet and we'll click on create exclusion. Okay, our status is active and only subnet C is excluded now. Let's go to our instances. We'll connect to instance C and try to connect. As you see, we are not able to connect to the internet. Now let's go to our instance D and try to connect by using IPv4 first. As you see, we are not able to connect. Now let's do the same command by using IPv6. And as you see, we are able to connect to the internet over IPv6 protocol. So in our next use case, we will change the mode of our block public access from bidirectional to ingress only. With the ingress only, all internet traffic to the VPCs in this particular region is blocked, and only traffic to and from the NAT gateways and egress only internet gateways is allowed. Which means that only the instances which are running in the subnet C will have access to the internet, and instances running in my public subnets like A and B won't have any access to the internet. So next, let's go to the console and we'll see how it works. So I am in my console and I've already turned on the block public access and I changed the direction as ingress only, and I deleted all our existing exclusions. Now let's go to the instances and try to connect to these instances. First, we'll take the instance C and try to ping. Here you can see that we are able to reach to the internet. Similarly, we'll go to the instance D and try to connect, and you will be able to connect to the internet. But if we try to connect to the internet from our instance B, which is running in my public subnet B, we won't be able to do that. Here you see we are not getting any response back. And similarly, if we go to our terminal and try to ping this instance from there, we won't be able to reach. In our last use case, we'll keep our BPA mode as ingress only, but we will exclude our public subnet A by using the bidirectional mode, which will allow the instances in this particular subnet to connect to the internet. So let's go to the console. And here you will see that I've started creating an exclusion for subnet A. We selected the subnet A, but I'm keeping the direction for this exclusion as a bidirectional. Let's select the create exclusion. Okay, so our status is active. That means my subnet A is excluded. Let's go and connect to our instance A and try to ping amazon.com. As you see, we are getting the response back. That means this is reachable. And if we try to do the same for our instance B, we are not able to connect. Next, let's try to connect to this instance over the internet from our terminal. And we are getting the response back. That means this instance is accessible over the internet. Let's try to do the same for our instance B, which is in my public subnet B and which is not excluded. And here you see that request is timing out. Thank you, everyone. And that was the quick demo showing the capabilities of VPC Block Public Access. Thank you so much, Sridhar.
Thank you, Ankush, and thank you everyone for listening to this presentation. And we really look forward to our customers and partners to leveraging this feature to the fullest. Thank you.
Thanks, everyone.